In this section, we're going to name alcohols. So again, we want to find the carbon with the longest chain, and we're going to name it with the longest carbon chain. In this case, it's butane. And what we do is, instead of butane, we'll drop the E and put an OL at the end of it instead. So it's butanol in this case. Up to this point, alcohol has a higher priority than alkynes, alkenes, alkyl halides, ethers, and so on. So up to this point, the alcohol itself will have the highest priority. If there is something on the group where the alcohol has lower priority, carboxylic acid is a good example of that, then the alcohol takes a lower priority and it's called a hydroxy prefix instead of calling the molecule a butanol or an OL at the end. And we'll see an example of that. So we go through naming the following molecules. I have 1, 2, 3 carbons. This is a propane. The molecule becomes propanol. I need to indicate where it is on the chain. It's in the 1 position. And the bromine is on the 2. So it's a 2-bromo, 1-propanol, or propan-1-ol. I can also write as well. So using the rest of the stuff there, I can actually say that this is a 1-ol instead, and move the 1 over to that position. For the next compound, we want to find the longest continuous carbon chain. That's the longest chains. Again, it's a propane group, so this is a propanol. And this time the alcohol is in the 2 position, so I'm going to call this a propan-2-ol. And also in the 2 position is a methyl, so this is a 2-methyl propan-2-ol. On the bottom left, we have both an alcohol group and a double bond group on the same molecule. The alcohol takes priority over the double bond, so if we were trying to decide which side to start numbering, 1, 2, 3, 1, 2, 3, the alcohol is on the 3 carbon, so this side is the highest priority. 1, 2, 3, 4, 5, 6. So this becomes a hexanol, and it's in the 3 position. So I can either call this a 3-hexanol. I can also call this a hexane 3-ol. And the double bond essentially is in the 1, 2, 3 position. I need to indicate that as well. So where we indicate that is here with the letter A. So I need to rewrite this. I could also write this as the 4-hexene 3-ol as well, and that would still work. And the last example, we have the alcohol on one end, and we have carboxylic acid on the other end. So to count the carbons, 1, 2, 3, 4, 5. The acid group has the highest priority. So 1, 2, 3, 4, 5. So this is going to be called, and we'll learn it later, but this is going to be pentanoic acid. That's going to be the last name for it. And now the hydroxy group, it's called a hydroxy instead of alcohol because it's lower priority. And it's on the 1, 2, 3, 4, 5 carbon because the acid takes the number 1 carbon. So I have a 5-hydroxy pentanoic acid. Common names are similar to the alkyl halides and the amines as well. So if I had a compound like this, and I had the alcohol here, and I wanted to use a common name for it, I'm going to use the alkyl group, and then just the word alcohol at the end of it. So this is going to be an alcohol of some sort. So if I look at it, I have 1, 2, 3, 4. This is a butyl. It's an isobutyl alcohol. If we had a 2-carbon chain and the alcohol, this is ethyl alcohol. Remember, this is a common name. This is not the IUPAC names for these. And a common name for this last one The group is a butyl group. The alcohol is attached in the secondary position, so this is a sec-butyl alcohol. You'll find these names typically used more commonly for the alcohols, also the alkyl halides and even the amines as well in industry. You can also end up with multiple OH substituents. This is very common, and we're going to name the longest carbon chain 1, 2, 3, 4, 5, 6. So we know we have a hexane. I know I have 2 alcohols, so somehow I have a diol, and I need to know the positions that they're in. So 1 is on the one side, 1, 2, 3, 4, 5, 6. So I have a 1, 6 diol, and I need to incorporate all of this into the name. I want the all at the end because it is an alcohol, and the di has to come with it. So I'm going to call this a hexane diol, and I can indicate that the 1, 6 position is where it's at. I can also rename this as a hexane 1, 6 diol. The E might go in here still. And I just checked, and yes, the E should be involved in the name. There's another common name for diols as well. If the diol is on adjacent carbons, for example, I have a propane group and I have an alcohol here and an alcohol here. We give these terms glycols as well, so you might hear these in antifreeze. There's ethylene glycol and propylene glycol. So you start with the carbon chain 1, 2, 3. This is a propyl group, so we're going to call this propylene glycol. Similarly, if I had just a 2 carbon chain and the OH is on this, this is 2 carbon chain, this is ethane, so I'm just going to call this ethylene glycol. The IUPAC names for this, this would be a 1, 2 ethane diol, and this would be a 1, 2 propane diol. The last alcohol type substituents we're going to deal with is when they're on an aromatic ring. So if I have an aromatic ring and an alcohol attached, it no longer is called an alcohol. It becomes a new name, and we actually call this a phenol. So when we get to the aromatic compounds, we'll deal more with this, but it has its own naming. In fact, if you have different types of substituents, you get new names. So the more complicated the molecules get, for example, methyl group on one side, hydroxy on the other, a common name for this is cresol. It's a commonly used solvent, but we'll get more into that into the aromatics.